If you want to send somebody a letter in the form of an email, even if that person is on the other side of the planet, it would only take seconds before it reaches that person. In the past, we did things very differently. We used birds, homing pigeons, to send our letters. How long would you think it takes for a bird to fly to the other side of the planet? Roughly. Weeks? Well, I did a quick calculation, and if it wouldn't rest and it knew exactly where to go to, it would take them about 10 days. Which is impressive, but if you compare 10 days to 1 second, well, that difference is huge. Communication hasn't been the only industry relying on animals. Transportation, the fastest way of getting to your destination was by riding a horse. And also for the heavy work on the land, we used animals. But at some point, we started innovating and we replaced these animals with machines. Today, we all have smartphones full of apps for communication. We invented the car that brings us to our destination in a very fast and comfortable way. And also in agriculture, we created these magnificent machines that help us with all kinds of tasks on the land. But we didn't stop there. We kept innovating. We're not only communicating from person to person on the same planet, we're actually communicating with a robot that's on a different planet. We're not only traveling over land and over water, we're traveling through space. We're flying through the sky and through space. And even when it comes to something like growing plants, we did not stop innovating. We're using smart sensors and robotics to grow large amounts of food, so we can do that inside cities and in deserts. So if you look at these three examples, you can see a very clear trend, where first we're relying on animals for thousands of years. Then we invent machines that can replace these animals, making the process much faster, much cheaper, much more reliable. And because of that, we can really start thinking about stuff that were unthinkable before and creating that. So if you look at that trend, you would say that all industries would already have gotten rid of the animals. Well, we all know that's not the case. So for me, it's all started about 2 years ago when I watched this documentary, and I wonder, because it's so local, how many of you have watched it? Yeah. And of course, I wasn't really excited about watching it because I knew it was going to show me what the impact would be of our favorite food. But it does give a clear trend. And we all know we are with a lot of humans on this planet. We love to eat meat. Because of that, there's a lot of land animals on this planet. By the end of today, we will have killed 200 million of them, just like we did yesterday and the day before. They need a lot of water. They need a lot of land. 30% of all land on Earth is used directly or indirectly for the meat industry. And on top of that, we also, of course, have the problem with the greenhouse gas emissions. Realizing all of this made it, I got pretty frustrated that day and pretty angry about the situation. Also because I knew that it was gonna be hard to convince everybody to become vegetarian or vegan. Even myself, I didn't turn into a vegan. But I did remember, of course, Mark Post, the professor who introduced the first ever grown hamburger grown in a lab. And I guess most of us really like this concept. And because it's, why would you grow this whole animal if you can also only grow the part that we're actually eating? At that time, I was still studying mechanical engineering, nothing to do with biotech or I didn't know anything about how to culture meat. But this hamburger took about 3 months in a small team to create. They had to make all these little muscle fibers to form this hamburger. And so I reached out, and I'm really proud to be part of this team with people from all over the world. Not Americans anymore, but we had them. And I invite any one of you who's interested in working with us to reach out. And they all came to our lab in Maastricht at Mosa Meat. And over there we are working on the machine that will replace these animals in these industries. So how would such a machine look like? Well, this is still a vision, but we'll be looking roughly like this. And we've seen some bioreactors before, but I want to go, it's a 5-step process, what you see here, and I will quickly go through it with you. So first of all, we still need these animals, so we still take the biopsy. And from this little tissue, if you zoom in, you see that you actually got some functional tissue. And on top of that, there is a satellite cell. And this satellite cell has the opportunity that whenever you're injured, you're worked out, it will go to the place of injury and start multiplying and start fusing back into real muscle fibers. So we're taking these satellite cells, and by bringing them in the right circumstances, they will start dividing. So after 24 hours, you see that they become 2. 24 hours later, 2 become 4. Well, you've heard the word exponential before today, but in the beginning it seems very slow. But you can imagine if you keep on doing this, and we're trying to extend this as far as possible, if you have 1 kilogram of these cells, the next day, only 24 hours, you will have 2 kilograms of these cells. And one of the big challenges, I would say, is not even growing these large amounts, but actually fusing them into real muscle fibers. Because that is the third step. We're aligning these cells and we're stimulating them to in such a way that they fuse together and they become premature muscle fibers, which already gives you the texture that you're expecting from meat. We need the 5th step where we're kind of training these cells and we're leaving them in the system to become matured, real matured muscle fibers. And these are actually functional muscle fibers that we started with at the beginning. We're bringing all these muscle fibers together, and that's how we end up with a burger. And of course, we are not going to stop here. The whole idea, I believe, of cultured meat is not about making veggie burgers that look like ground meat, which you can already do quite well with Impossible burgers or Beyond burgers. I think by making real tissue, by getting larger tissue and making them actually functional, then there's no debate anymore why you would choose a steak from an animal or a steak from a machine. So how are we going to convince these farmers that it's time for the next generation and stop investing in animals and start investing in machines? I mean, in the end, this farmer also decided to buy a tractor instead of buying a horse. So the question is, how do you compare these machines with animals? And something very similar happened about 200 years ago when the first engines were introduced. Also a unit which we're all familiar with, the horsepower, was also introduced to make this comparison. So the question is, what is the horsepower of cultured meat? Well, when it comes to meat, it's all about production, it's about production speed. So let's look at a cow. How fast does it produce? And let's start with a single cell again, conception. It takes about 9.5 months before the calf is born. And then in normal circumstances, it can grow up to over 20 years of age. But it's born in an industry that is focused on efficiency. So if you're in the dairy industry, you will be slaughtered at an age of about 7 years. But if you're in the meat industry, you most likely are not going to make it up to your 2nd birthday. So in total, we're talking about 780 days. Keep this number in mind. So how much did it grow in that time? Well, the cows on average will become 630 kilograms. But not always edible. We have blood, intestines, brains, skin. And from the carcass, you still have to get rid of the bones. We're not eating those. And then you're left with only 50% of what it was, which is about 315 kilograms. So one cow produces 315 kilograms in 780 days, which is about 400 grams per day, or 14 ounces. So question to you, how are we going to call this? How are we going to call the horsepower of cultured meat? Any suggestions? Cow power, yeah. So we did a quick brainstorm in the lab and with the students, and we came up with cowpacity. The capacity of one cow when it comes to meat production. So how would that look like? How would the machine look like that can replace one cow with current technology? And I did some calculations based on what we're doing now, and it would be a machine that's about 1 meter wide, 2 meters high, and 2.5 meters long. Which is, I would say, pretty reasonable, because if you would fit a cow into a tight cage, this cage would have kind of these dimensions. But we're talking about technology. And I believe that I'll be looking back at this presentation and what I'm showing you right now, and I'll probably be laughing at the size of this machine that I'm showing you here. Again, as was mentioned before, we're not there yet. Even if the technology is in place, we still have to go through regulation. And before this is implemented all around the world and having the impact that we're actually looking for, it will take many years. And therefore, I want to encourage you, any of you who wants to, as a consumer, if you want to have an impact already, to go for the plant-based foods and go for these alternatives. And they are becoming better and better over the years, is what I reckoned. Still, I think many of us would love to enjoy the taste of meat without all the consequences that we're facing. So I want to conclude with this. Even if we did something for a very long time, it doesn't necessarily mean it was the right way or even an optimum way of doing it. We have to keep embracing and keep inventing alternatives like plant-based foods and meat machines, because only then we can create a future with a planet that is sustainable, where people are healthy and not suffering from hunger, and where we are treating the animals with respect. Thank you very much.